Hi friends, this is Dr. Jayashree Joshi and I'll be talking to you on impression materials, the introduction part, the materials, the classification, ideal requirements. So first we'll have to find out what do you mean by impression. Now, do you think impression is a measurement? I think yes. So first we'll have to find out about measurement. Now measurements, when we see the measurements, there are different ways to measure different things. Now here you can see a measurement is being carried out with the help of a measuring tape. Here a measuring cylinder or a jar is used to measure the liquid. Here measurement in geometry, measurement of the heartbeats with the help of ECG, measurement of the temperature with the help of thermometer. So there are the different devices to measure certain things. Now there is one more thing which is called as imprints. Now imprints are also measurement, but they are somewhat different than the previous measurements. So what are these imprints? So imprints are nothing but the mark which is made by pressure. So in the first picture you can find a thumb is being pressed on a paper and you got the print of the thumb. Similarly in the second picture, a foot is pressed on the sand and we got a footprint. So the difference between the first and second was in the first measurements, some devices were used and instruments were used, and in the second one, a pressing has been carried out and the marks are obtained. So that is the basic difference between the first picture and the second picture. Now, this imprint is more close to impression. So impression is a very commonly used word in day-to-day life. I got a very good impression about that person, or we often say that first impression is a last impression. So what does that impression mean? So basically it is an idea, feeling or opinion about something or someone. It is the event when one person encounters other person and forms a mental image of that person. Many times we meet some person, we talk with that person, we spend some time with that person, and we form some ideas or some image about that person and we call it as an impression. Now we have to relate all these things with dentistry, because in dentistry, impression plays an important role. As all of us are aware that in dentistry, indirect restorations are used. Similarly, we give dentures to the patients, orthodontic appliances, or maxillofacial prosthesis to the patients. Now, one of the essential requirements of these processes or restorations is its fit. So to ensure the accuracy of the fit, the fabrication of these restorations is best carried out inside the oral cavity. However, it is not always possible. So, a duplicate reproduction of the desired part or the area in a durable material is necessary for indirect fabrication in the laboratory. And there comes the importance of impression. Now, impressions are used to create mouth guards, bleaching trays, retainers, crowns, bridges, veneers, dentures, maxillofacial prosthesis, and accurate models in dentistry. Basically, the impression materials which are used to make the impressions are auxiliary materials, that is, they help in the process of fabrication of the prosthesis. Now this cast is not made of an impression material, but the impression which has been made. In that the cast material is poured to get the cast. So this is a diagnostic cast. Similarly, the impressions are used to get the working models, study models, then dentures, complete dentures, removable partial dentures, crowns, then orthodontic appliances, maxillofacial prosthesis. So for all these things, the major part is impression. So now what is an impression? Impression is defined as the negative replica of the teeth and the associated tissues. That's a very simple definition. Negative replica. Now what do you mean by negative replica? I'll show you one picture. In this you can see a photograph. In this photograph, one part of the photograph is showing a negative image and other part showing a positive or a developed image. Now a negative image is that in this image the areas of the photographed subject appear different. That is, the lighter areas appear darker and the darker areas appears lighter, and that's why we call it as a negative. Similarly, when you make the impression, suppose we have made the impression of the dentulous arch. So whatever concavities are there, they are seen as convexities, or you can say whatever depressions are there in the oral cavity, they are seen as elevated portions in the impressions. Similarly, whatever elevated portions are there, they are seen as depressions. So exactly opposite is seen in the impression, and that's why it is called as a negative replica of the oral tissues. Now what do you mean by impression materials? So any substance or combination of substances used for making the impression are the impression materials. And there are n number of materials which are used in dentistry for making the impressions. Now here are few impression materials, that is impression paste, then alginate, then impression compound, low fusing impression compound, addition silicone, putty. So these are the different materials which are used for making the impressions. Now before going further for any materials, American Dental Association has given ideal requirements for each and every material. So same is applicable to impression materials also. So first we will discuss about the ideal requirements of the impression materials. Now the first and the most important ideal requirement is biocompatibility and chemical properties. Now usually whenever we discuss the ideal requirements, the requirements are discussed on the basis of the properties. So the first property is biocompatibility and chemical properties. Now when I say biocompatibility, it is a term which describes the property of the material being compatible with living tissues. That is, biocompatible materials do not produce a toxic or immunological response when exposed to the body or bodily fluids. And chemical properties are those properties. Chemical properties, that is whether the material is inert, whether it is acting with any other material. So the first group of requirements are based on biocompatibility and chemical properties. So the first one requirement, the material should be non-poisonous, non-irritant, non-allergic to the oral tissues. Then it should have acceptable taste and odor, because you are carrying the material inside the oral cavity. Now some of the materials, they set or harden inside the oral cavity and they take a longer time. So it should be agreeable to the patient, and that's why it should have an acceptable taste and odor. Now it should be chemically inert in the oral conditions. Now chemically inert means chemically not reactive, means it should be stable and unreactive in oral condition. It should not react with any of the oral fluids. Then it should not absorb the saliva or oral fluids. and dissolve in it. Otherwise, it will affect the dimensions of the impression. It should be preferably hydrophilic. As you know, hydrophilic means affinity towards water. Now, the oral cavity is full of saliva, it's flooded with saliva. So, if the impression material is hydrophilic, it will flow readily over the underlying tissues and proper impression can be recorded. It should be compatible with the die and cast materials. So these are few ideal requirements which are based on biocompatibility and chemical properties. Now next group of ideal requirements are based on the mechanical properties, that is the material should have adequate compressive strength. Now as I told you, impressions are made by compressing the material, pressing the material against the tissue, so the compressive strength should be adequate. Second is the tear strength. The material should ideally have high tear strength. Basically, tear strength is a measure of how well a material can withstand the effect of tearing. From standpoint of clinical application, material should have high tear strength, means it should exhibit maximum energy absorption without tearing and with minimal distortion. If the material has very low tear strength, then while removing the impression from the oral cavity, especially from the undercut areas, there is a chance of tearing of the impression. And in such cases, to avoid the distortion, the thickness of the impression material should be increased. Now, the third important criteria is high elasticity and complete elastic recovery. The material should be preferably elastic, because in the oral cavity, when the arch is dentulous, preferably, the undercuts are bound to present. Now, in case of undercut areas, preferable material should be elastic in nature. Then only it will be easier for you to remove the impression without distortion or without fracture. So ideally the material should be highly elastic. Now when you say highly elastic, the second word comes, that is elastic recovery. Now whenever the elastic material is removed from the oral cavity, that is when the stresses are released, the elastic deformation should, the material should go back to its original position, because while removing the impression from the oral cavity, the material has distorted or deformed elastically. So on release of stresses, the material should go back to its original. So complete elastic recovery means the material should go back and should resume the exact original dimensions. So that's why the impression material should be highly elastic and it should have complete elastic recovery. Then the next important requirement is high flexibility. Now what do you mean by flexibility? Flexibility is defined as a maximum strain which is seen in the material when it is stressed not to exceed its proportional limit. So within the limit, whatever changes are occurring or whatever deformation is occurring is mainly elastic type of deformation. Now when I say high flexibility, that means within the limit, with the slightest application of the stress, the amount of strain seen is very high. So amount of strain is high, so it is defined as maximum strain. Now this property is specifically important while removing the impression from the oral cavity. Now, because of the elasticity of the material, you will be able to remove the material from the undercut areas because of its elastic nature. But because of the high flexibility, an application of little stress, that is application of little forces while removing the impression, a maximum elastic deformation is seen in such materials, and the impression can be easily removed from the mouth without causing any discomfort to the patient. That is the significance of high flexibility. So the material should have high flexibility. Now the next group of requirements are based on rheological properties. Rheological properties means the properties related to the flow of the material. Whenever the term impression comes, the second term should come about its flow. So the impression material should have very good flow, or you can say they should possess low viscosity. Now, when during setting, that is, you have to carry the material inside the oral cavity, and inside the oral cavity against the tissues, the material hardens. So during insertion, the flow should be good, but once you have pressed it against the tissues, then the viscosity should increase rapidly. Then it should have suitable mixing and working time. That is, you should get suitable time, or you should get sufficient time to mix the material, to load the material, and to carry the tray inside the oral cavity. So you should have sufficient working time, but the setting time, the hardening time inside the oral cavity should be less. Now the next group of ideal requirements are very important, which are based on thermal properties. The first is in case of thermoplastic materials. The material should have low softening temperature and high thermal conductivity. High thermal conductivity basically for the uniform softening of the material. Then it should preferably be having low coefficient of thermal expansion. Now what do you mean by coefficient of thermal expansion? So basically it is the change in length per unit length of a material when its temperature is raised or lowered 1 degree. That is, with the change of temperature, whether it is increase in the temperature or decrease in the temperature, the changes in the dimension of the material is your coefficient of thermal expansion. Now, whenever we are talking about the coefficient of thermal expansion of impression material, it is either high coefficient of thermal expansion or low. Now, when I say high coefficient of thermal expansion means the material changes its dimension with the slightest change in the degree temperature. That is, with the slightest change in the temperature, more changes are seen in the material. Now, change in the temperature means the oral temperature is usually 37 degrees centigrade, and when you take out the impression from the mouth, the outside temperature may be high and may be low. So, in case if the material has high coefficient of thermal expansion, with the slightest change in the temperature from the oral temperature to the outside temperature, will affect the dimensions of the impression. So ideally the material should have low coefficient of thermal expansion. That means with the minimal difference in the temperature between the oral temperature and outside temperature will not cause much effect on the dimensions of the impression. Then the setting or hardening temperature should be preferably at the oral temperature. Now coming to the dimensional stability. Dimensional stability means the material should remain stable in dimensions. That is the degree to which a material maintains its original dimensions when subjected to changes in temperature and humidity. So ideally, the material should be dimensionally stable, especially between removal of the impression from the mouth and pouring it for the cast. So dimensional stability is very, very important. There are various causes which affects the dimensional stability of the material. Now there are n number of miscellaneous properties which are equally important whenever we are discussing the impression materials. That is, material should adhere to the tray but not to the tissues. If it is not adhering to the tray while removal of the impression, there may be a separation of the impression and the tray. Now the adhesion We can get the adhesion by means of different ways. That is, adhesives are available, or you can use perforated trays, or you can seal the material over the tray. Then, in case of two-piece system, a good color contrast is required. Now, many of the impression materials are available in the form of two-piece system. Now, basically, whenever two pieces are there, they are supplied in the different colors, especially the color contrast has to be there. Now, this color contrast should be there to know or to identify whether you have mixed it homogeneously or not. Then the material should have long shelf life, that is, you can store material for a longer duration. It should be preferably inexpensive. Then material should be able to sterilize easily, and after making the impressions, disinfection should be carried out without loss of accuracy. So this is a very important requirement from the impression materials. Then it should be easily available, easy to dispense, proportion, and mix with minimal equipments. So these are few ideal requirements of the impression materials. My dear friends, although these requirements are given by American Dental Association specifications, not a single material specifies or satisfies all the ideal requirements. Now coming to the classification of impression materials, there are various ways by which we can classify impression material. Now the first way of classifying impression material is according to the nature of setting, how the hardening of the material is carried out. Now there are two ways by which the hardening is carried out. The first way is a physical change. Physical change means by the change in the temperature, the material sets or hardens. That is, at higher temperature, the material is soft, and at room temperature, the material hardens. So there is no chemical reaction occurring. It is strictly a physical change. So such materials are called as reversible materials. Examples are impression compound, agar, and impression waxes. Now the second group is irreversible, that is where the setting occurs by chemical changes, that is a chemical reaction occurs. So the initial product is different from the final product, and the final product cannot revert back to the initial product, and that's why it is called as irreversible. The examples are zinc oxide original impression paste, then alginate and elastomeric impression materials. So this is one way of classifying impression materials according to the way of setting, physical changes and chemicals. According to the elastic behavior after setting. Now whether we have to see whether the material is elastic or inelastic after setting. Now this property is seen after setting. So according on the basis of this, the materials are classified into two groups, elastic and inelastic. Now elastic are also called as non-rigid type of materials. Examples are hydrocolloids and elastomers, and inelastic or also called as rigid type of materials. They are not at all elastic after setting. So examples are impression compounds, zinc oxide original impression paste, and impression plaster. So this is another way of classifying impression material. Now the next way of classifying impression material is according to the viscosity or according to the flow. Now according to the flow, the materials are basically classified into two groups, that is mucostatic. Now when I say mucostatic, static means stable. Mucostatic, that is underlying tissues are remaining stable. Now when it is possible, when the material has got very good flow, when the material flows readily inside the oral cavity, then only it will be able to record the underlying tissues in a static condition. So such materials are called as mucostatic materials. The classic example of mucostatic material is impression plaster. Now the second group is mucocompressive. Exactly opposite to mucostatic is a mucocompressive, that is, you are compressing the underlying tissues. Now, when this will happen, if the material does not have good flow, then to make it flow inside the oral cavity, you have to press the material against the tissues. Now, whenever you are pressing the material against the tissues, you are pressing the underlying tissues also. And that's how you are compressing the underlying tissues, and that's why the materials are called as mucocompressive materials. And the classic example is medium fusing impression compound. In some of the books have mentioned about the pseudoplastic material also. Now, pseudoplastic material means initially the material looks viscous, but on application of little pressure, the material flows readily inside the oral cavity. Now, the next way of classifying impression materials is according to the dispensing system, the way it is dispensed. So, either it is dispensed in the form of powder, examples are impression plasters and alginate, then single pass system, light activated polyether, then two pass system, that is zinc oxide original impression paste, polysulfide, polysilicones, three pass system, that is chemically activated polyether, then gels, that is example is agar, and some materials are available in the form of cakes, cylinders, sticks, sheets and cones, that is impression compound and impression waxes. And the last way of classifying impression material is according to the use. According to the use, we have to classify it into two groups, that is materials used for dentulous arches and materials used for edentulous arches. Now, as I said, only elastic materials can be used for dentulous arches, and for edentulous arches, both elastic and inelastic materials can be used. So, these are the different ways by which we can classify impression materials. So, the first two are the basic uh, ways of classifying impression materials, that is the way of setting and according to the elastic behavior after setting. Now coming to the impression compound, which is one of the impression materials. Impression compound is one of the impression materials. It is a rigid, that is inelastic material, reversible in nature, that is it sets by physical changes. It is mucocompressive because the material does not have good flow. And it is, as it is inelastic in nature, it is used to make impressions of edentulous arches. So impression compound is a rigid, reversible, mucocompressive material used to make impressions of edentulous arches. So this is an edentulous arch. This is the impression compound in the form of a cake, and this is the way the impressions are made with impression compound. Now, according to ADA specification, there are two types of impression compounds which are available, that is type 1 and type 2. Now, type 1 is called as a true impression compound, which is mainly used to make the impressions, and type 2 is used as a tray compound. Okay, so according to ADA specification, there are two types, that is type 1 and type 2. There's another way of classifying impression compound is according to the fusion temperature. So according to it, they are classified as low fusing, medium fusing and high fusing. Now, out of that, low fusing and medium fusing comes under type 1, that is the true impression compound, and high fusing comes under type 2, that is tray compound. Now coming to the composition. So this is a very simple composition, that it contains resins, thermoplastic resins, copal resins, carnauba wax, stearic acid, talc and coloring agents. Out of that, the waxes and the resin forms the matrix of the impression compound. Basically, the waxes are very brittle in nature. So to improve the plasticity and workability, plasticizers are added. Now, the common plasticizers which are added are shellac, stearic acid, or gutta-percha. Similarly, if only the matrix is used, then it will result in relatively high flow and low strength even at room temperature. So consequently, feelers are added to improve the flow as well as the strength of the material. So commonly used feeler is talc, and of course coloring agents are added. So this is a very simple composition of impression compound. Now, impression compound sets by physical change, so there is no chemical reaction as such. It is a thermoplastic material. It softens on heating and hardens on cooling. Very simple setting reaction. Now, it is dispensed in the form of sheets, cones, cakes, and sticks. Now, the sheet is the medium fusing impression compound, and the sticks which are shown in the next diagram is a green stick compound, or also called as low fusing impression compound. Now first we'll discuss the manipulation of impression compound. Now manipulation is discussed under three headings, that is ratio, the instruments used, and the manipulation proper. Now this is a single component system, so there is no ratio as such, but whenever you are making impressions, for maxillary impressions, one full cake is required, and for mandibular impressions, half to 3/4 cake is required. So that you can say a ratio. Now the instruments used. Now basically it is a thermoplastic material. So you need a plastic mass for making the impression. So for softening the material, the equipment which is used is called as thermostatically controlled water bath, in which the temperature can be controlled because we need to keep the temperature between 55 to 60 degrees centigrade. The other instruments used are the impression trays, then the wax knife for the manipulation of the material. So this is in the first picture, we can see the impression compound cake. In the second picture, we can see the thermostatically controlled water bath. In the third picture, pieces of impression compounds are made. Now why the impression compound is not put in toto in the thermostatically controlled water bath? Why the pieces are required? Because the thermal conductivity of impression compound is very low. As the thermal conductivity is low, if you put a complete cake, only the outside material will get soft and the inside material will remain hard. So to get a uniform softening, it has to be broken down into small pieces before putting it inside the bath. Then in the last diagram, the impression trays are shown which are used to make the impressions with medium fusing impression compound. These are the non-perforated type of stock metal trays. Now for the practical purpose, we are using a rubber bowl in which hot water is taken. The pieces are put inside the rubber bowl. Usually a gauze is placed inside the rubber bowl so that sticking of the material to the ball is avoided. So you have to do the kneading of the material to get the homogeneous softening, then make a ball of it, and then you have to place the material over the tray, spread it over the tray, shape it like an impression, and then place it inside the oral cavity. So this is regarding the manipulation. So this is the way we carry the material inside the oral cavity. As the material does not have very good flow, we have to apply a little pressure so that the material flows readily inside the oral cavity, and this is the impression which is being made with medium fusing impression compound. Now coming to the properties. The first important property again is a biological property. So it is a non-toxic, non-irritant type of material, non-poisonous material. It does not cause any allergic reactions to the underlying tissues. Then rheological properties, that is the properties related to the flow of the material. Now the flow of the material, according to ADA specification, it should not be more than 6% at 37 degrees centigrade, and it should not be less than 85 degrees centigrade at 45 degrees centigrade. 85% at 45 degrees centigrade. Now 45 degrees centigrade means usually the temperature at which you are holding the material inside the oral cavity. So flow should not be less than 85%. But the impression compound does not have very good flow, and to make it flow you have to compress the material against the tissues. Now to increase the flow, we can do the wet kneading, which is one of the way to improve the plasticity and to improve the flow of the material. Now the next important properties is thermal properties. Now there are three thermal properties which we need to discuss whenever we are discussing the impression compound. And the first property is fusion temperature. Now what do you mean by fusion temperature? So it is the temperature which indicates a definite reduction in plasticity during cooling. Definite reduction in plasticity during cooling. That means above this temperature, the fatty acids are liquid and plasticize the material to form a smooth plastic mass. So usually above this temperature, the material is quite soft and will be able to make the impressions very easily. And the fusion temperature for medium fusing impression compound is 43.5 degrees centigrade. So ideally, the significance of this temperature is that ideally the impressions should be made at or above the fusion temperature. Okay. Second is the glass transition temperature. Now glass transition temperature is the temperature at which there is an abrupt increase in thermal expansion coefficient indicating increased molecular mobility. Now this is a very complicated definition, but you can say simply that above this temperature that there is a transition, or at this temperature there is a transition from rigid state to more flexible state, or at this stage the material loses its hardness, in simple terms. So what is the significance? See, below this temperature the material is rigid, the material is hard. So the significance is that the material, the impression made with impression compound should be removed at or below the glass transition temperature. And the glass transition temperature of the impression compound is 39 degrees centigrade. So these are the two important temperatures with its clinical significance. Fusion temperature 43.5 degrees centigrade. At or above the fusion temperature, the material, the impression should be inserted inside the oral cavity to make the impression, and at and below the glass transition temperature, which is 39 degrees centigrade, the material should be removed from the oral cavity. Now next property is thermal conductivity. The thermal conductivity of the material is low. The clinical significance is that as the thermal conductivity is low, the material will not soften uniformly, and to make the material soften uniformly, you have to break into small pieces, so each and every part of the material will come in contact with the heat. Then the next important thermal property is coefficient of thermal expansion. As we have already seen during the ideal requirements, that one of the ideal requirements of the impression material is that the material should have low coefficient of thermal expansion. But in case of impression compound, the coefficient of thermal expansion is slightly high. So it is the cause for the dimensional changes if not manipulated properly. Now last property is dimensional stability. Dimensional stability means the material should remain dimensionally stable, especially when after removal of the impression from the mouth till the cast is poured. Now, in case of impression compound, because of the bad thermal conductivity, as I said, the material doesn't soften uniformly. The same way the material doesn't harden uniformly also. That is, in the soft condition, you have inserted the material inside the cavity, you have pressed it against the tissues, and you have to hold the material till the material hardens completely. Now, during hardening also, the outside material hardens faster, and the inside material, it takes little time to harden. So if you don't keep, or if you don't wait sufficient time, or for the complete hardening of the material, then it will show dimensional changes after removal of the impression from the oral cavity, and this is mainly because of the relaxation of the stresses. So this is one of the disadvantage of this material, that is, if not manipulated properly due to the bad thermal conductivity, the dimensional changes occurs. Coming to the advantages, the material can be reusable, but reusable only in the same patients, and you cannot use it for more than 2 or 3 times, otherwise it will lose its property. Then no spatial trays are required because you can use a readily available tray as the flow of the material is not good. No separating medium is required when you are pouring the impression. It is compatible with die and model materials. It can be electroplated. It can also be used for boulder molding procedures. Small defects can be corrected easily because it is thermoplastic material. If some defect comes, you can just resoften that area and you can place the same impression inside the oral cavity. Ease of availability and very easy to manipulate without the use of very expensive equipments. So these are the advantages, and relatively inexpensive. Now coming to the disadvantages. Yes, very easy. It cannot be used in dentulous patients because they are inelastic in nature. Secondly, as the flow of the material is not good, to make it flow, you have to press the material, so it compresses the underlying tissues. Then because of the high viscosity, it does not record the minute details, and that's why it is mainly used for making preliminary impressions and not the final impressions. Then it has got large coefficient of thermal expansion, which leads to dimensional instability. Then it is a bad conductor of heat, so it may not result into the complete softening, uniform softening. If not tempered properly, then burning of the underlying tissues can occur. So these were the disadvantages. Now coming to the uses of the material, uses of the medium fusing impression compound. So basically it is used for preliminary impressions of edentulous dental arches. Secondly, it was used for reinforcing the special trees made with shellac. I use this word because nowadays we are not using shellac for making the special trees, but initially, few years back, shellac was the material of choice for making the special trees. In that case, to reinforce the shellac, the medium fusing impression compound was used. And for checking the undercut areas in an inlay preparation, impression compound can be used. But the major use or the basic use is preliminary impressions of edentulous dental arches. Now, whenever you are manipulating the material, you have to take certain precautions. That is, you have to maintain the temperature of the water properly. That is, ideally it has to be 55 to 60. If the temperature is lower than 55, then it may not soften the material properly. If it is more than 60 degrees centigrade, then due to high temperature, some of the plasticizers might leach out of the material and make the material grainy. So this precaution you have to take while softening the material. And while softening, the material is broken down into small pieces to get the uniform softening. So these precautions has to be taken. Now coming to the low fusing impression compound, which is available in the form of sticks. It is a type 1 impression compound, which is inelastic, reversible, and of course mucocompressive. Now it is available in the form of stick, and softening can be carried out by two ways, that is over the open flame if the material required is less, and hot water bath if the material required is more. Now same can be applied to the medium fusing impression compound also. You can use either dry heat or wet. Now dry heat only can be applicable if the material required is less. In case of full impression, if you soften it over the flame, then you may not get uniform softening, and that's why whenever bulk material is required, it has to be softened in water bath. Now this is used for powder molding procedures before final impression. So uses of low fusing impression compound, border molding of the for the peripheral extension of the spatial tray. Then it is also used as a single tooth impression. Now initially, uh, single tooth impression was made with the help of copper band, which is also called as a copper band impression. So in that cases, low fusing impression compound was popularly used, but nowadays some other good materials, impression materials have been introduced. So we are no longer using low fusing impression compound for single tooth impressions. Now, low fusing impression compound can also be used for the impressions of the resorbed mandibular ridges, over which we can take the impression with the help of a free flowing material. So to summarize, we have seen impression materials, we have seen its classification and ideal requirements, then classification and types of impression compound, composition, role of ingredients, manipulation, advantages, disadvantages, identification, classification, and uses of low fusing impression compound. So these were my references. Thank you so much for the patient listening.